Yeah, okay. We can go ahead and get started. So everyone's here. Thank you for joining us. My name is Lucas Stiim. I'm with Amtek Company. If you don't know who Amtek Company is, we are the regional providers of technical training and technical equipment in the Mid-Atlantic area. We can fill your classrooms or makerspaces with a lot of technical equipment like 3D printers, lasers, and a bunch of other stuff. We actually have our brochure that we're going to put into the chat that you can kind of download and look at. I actually have it open on my screen right here, and I can just scroll down to the like table of contents here, and this is just a small list of some of this type of stuff we do. If you have any questions during the entire webinar, please put them into the chat or the Q&A section, and we'll go through them at the end. And if you have any questions sales side, you can email info@amtekcompany.com. So what we are going to be doing today is reverse engineering a 3D model. And we're going to be doing that with two pieces of equipment that we provide, 3D scanners and FDM 3D printers. I'm going to go over in a little bit exactly which ones I'm using. But basically what we're going to be doing is taking a broken part of a mechanical system. And if you want to go to the hand cam, I can kind of show it. So these are all printed on the machine that we'll be using today to print the new part. But this is just a couple of 3D printed gears that, should spin. And there's a hole cut out in one of them. So this represents our broken part. So what we're going to do is we're going to scan this part, process it through the software, bring it through a CAD software, and then eventually 3D print it and make a working functional part and maybe an even more efficient working part than just a normal gear. So our agenda for today is the introduction I just went through, some 3D scanning and 3D printing use cases. The 3D scanner and the 3D printer goes really well together. For this type of reason, projects are really easy to make with these two types of machines. We'll go over the different products that I'll be using today and some of the other stuff that they offer. And then we'll actually get into the demo of how we'll reverse engineer the part. And then lastly is the Q&A. So, introduction, we're going to be using this 3D scanner. This is a 3D scanner by Creaform. This is the Go Scan 3D, their mid-range scanner. It uses basically a bunch of cameras that take a lot of pictures really fast and send data to a computer, and then we can manipulate that data. And then behind me, the printer we'll be using is this big thing right here. This is the Stratasys F170. We also provide this. This is an industrial grade FDM 3D printer. Both of these machines are very accurate. The Stratasys can do a lot of different types of materials like ABS, ASA, and flexible material like TPU and a couple other ones. So some project examples that you can use with both of these machines, obviously fixing the part, which is what we're going to do today. You can modify parts for rapid prototyping. You can create parts that aren't really supposed to be handheld. We have a customer that has these two types of machines in a museum, and they'll scan the relics that they don't want people to hold, and then now they have a 3D part that people can hold. And then this type of scanner can capture color data as well. And Stratasys also offers a printer, which is on my other side. This one is the J35. This can do, it can print in grayscale. And then they have the bigger version, which is the J55, that can do CMYK full color. So you can do something, if you go to the hand cam, this is a 3D scan of a peach that's printed out on a J55. And this is completely plastic, but it looks like a peach. And we also have a slice of pizza as well. They look pretty real. So that's just some of the projects you can do. So product lines of what I'll be using, I kind of went over them already, but Stratasys, this one on my side here, this is the F series, this is the F170. This is their kind of their lowest model, but it's still really highly accurate, and a lot of schools use it, and it's good enough. They do have some upgraded ones that use more material or have bigger print volumes. And then on the other side, we have the J series, which I talked about. The 35 does grayscale. These are polyjet machines, not FDM. So it uses a liquid resin that's then cured. So you can get some really high detailed parts. So I have some here. So these are both on the ones that the one we have behind us, but they're very high detailed parts. You can see the grayscale on this sculpture. And then this one's like a boat, but it looks really good. And then, so I would say on the J series, more like artsy sculptures, and then on the FDM, more like engineering type models. So this one is a more FDM type 3D print. And then for the scanners, the Creaform provides a lot of scanners at a lot of different price points. Like I said, this one is a mid-range one, and this one uses cameras to capture data. There are also ones that use lasers to capture data. And the laser ones, I believe, are more accurate and can capture data at in a wider range. Some people will scan whole vehicles. So you can go pretty far with it. Okay, so more about what we're going to be doing today. I'm going to kind of go over in my PowerPoint just each step that we're going to do, and then I'll actually do them. So first is we're going to scan the part. For this scanner, it's important to calibrate it every time before you use it during the day. I've already calibrated this one, and it's a pretty easy thing, and we would show you that in the training if you purchased the piece of equipment. We actually here, if you go to the hand cam, we have this kind of like Lazy Susan that we built with these positioning targets on them. These positioning targets are picked up by the laser, and they help line up our piece because we'll be doing multiple scans and we'll have to merge them. And these points will help us do that. And this way, I don't have to turn my scanner around. I can just turn the Lazy Susan and it kind of turns it for me. It's important to move pretty slow and at a consistent speed while scanning so you kind of get as much data as you can. When you buy a Creaform scanner, it comes with the software VX Elements. This is a software suite that comes with a bunch of different softwares inside of it. So the first one is VX Scan. VX Scan is where we're going to capture our scan data. And then once we've captured the scan data, cleaned it up, and merged the multiple scans into one 3D model, we can send over to VX Model. This is where we'll clean up the scan, fill holes, and then eventually create entities that we can bring over to a CAD software like SolidWorks, which is where we would reverse engineer the part. And I'm going to show you all of this. There's a bunch of other softwares in VX Elements that I'm not going to go over today. One of them is VX Inspect. This is a tool that lets you kind of stress test your part for water tightness, measurements, a bunch of inspecting tools. And there's a couple other ones, but we won't go through this. Once we've scanned our model, we want to prepare it for SolidWorks. We're going to do this in VX Model, and we would create basically entities from our scan, like shapes or planes that we would move over to SolidWorks, and then we'll use those shapes and planes to basically make a new part. And again, I'll show you all that once we get to it. So this is saying the same thing. I'm using the reference geometry that I brought over from VX Model, recreate our new part in SolidWorks. And then finally, once our part is done in SolidWorks, we can put it into a 3D slicing software. 3D slicers are used for 3D printers to basically turn an STL file or a 3D file into the file type that the 3D printer can use. It will slice it layer by layer, and then the printer will rebuild those layers. Today, we'll be using GrabCAD Print, which is Stratasys's main slicer software, and I'll get into that too. Okay, so that's it for the PowerPoint. We can actually start scanning something. So I'm hopping over to VX Elements, and my scanner is already connected. It says detected right here, the Go Spark. So I can just hit New Scan, and it will load VX Scan. As soon as it opens. Okay. So the first thing I'm going to do before I start scanning my part is I want to just scan my positioning targets. That way I can bring those positioning targets to each of my scans so it's lined up correctly. I can also make a clipping plane so the scanner won't scan anything below those targets. So the first thing I'm going to do is I'm going to hit the drop down here. I'm going to hit Scan Positioning Targets. And I'll grab my 3D scanner. Hit the buttons on the side to start scanning. And you can see the targets starting to show up. And it's, like I said, it's only scanning the targets right now. The colors indicate distance. So if I'm too close, they'll be red. Green is a good distance, and then blue means I'm too far away. So you want to try to keep it green whenever possible. That's perfectly fine. It doesn't take a very long time to scan the targets. So we have that data. I'm going to end the scan. And now I'm going to add a clipping plane. And I'm going to select 3 of these targets. Zoom in. And now I hit create. And now anything under that plane that I just created, like I said, won't be scanned. And this will save us from cleanup later. So now we're kind of ready to do our first scan of our parts. Something important to note, when scanning a 3D model, if it's symmetrical, kind of like this, obviously there's a broken part in it, but say it was the full one, because this is symmetrical both ways, if I were to scan it like that, and then flip it over and scan it like that, when I would try to merge the 2 scans into one, the software is not going to know that these are 2 different sides because they look exactly the same. So to resolve that, I put 2 little pieces of tape on my broken one, and I'll use these pieces of tape to help line up the 2 scans, and there's no tape on the other side. And you'll see that once I get to that point. So another important thing is to try to get as much surface area when you're scanning. If I lay it down like this, I'm missing out on a lot of surface area that I could be getting in one scan. So I'm going to stand it up like this and just kind of be careful when I spin the Lazy Susan. It is important to not move your part while scanning, but you can move it something like this as long as it's moving relatively to the positioning targets. So I have my part set up. I'm going to hit scan, grab my scanner, and I'm going to start scanning. My clipping plane didn't do very good because it's grabbing some of it, but that's okay. I want to try to make it green, make the gear green, basically. And the more time you take doing this, the less work you'll have later, because we are going to have to go back and clean things up, fill holes, and delete all of these other things like the table that I'm picking up right now. That's okay. In my hand. All right, that's probably good. I can kind of zoom in and see how well I did. I'm going to stop the scan. Okay, so it's not perfect, but we're going to do a second scan, and hopefully that second scan will grab the rest of that data that we kind of missed. Before I do that, I want to get rid of all of this extra stuff that I scanned. So what I'm going to do is I'm going to hold Control, or I'm going to select this button first. This is the Connect button, and then hold Control and select my part. What that's doing is any part that's connected to the point in space that I selected will highlight. So that's why my part turned orange. Now I'm going to hit Invert Selection, which is going to choose everything else. So anything not connected to the part that I selected, and I'll hit Delete. And that should get rid of all that junk. Sweet. Okay, so we have just our part. So that's our first scan. I'm going to hit Add a Scan at the top right here. I want to bring over my positioning targets and my clipping plane, and that's all that's asking. I'm going to flip my part 180, and we can start our second scan. And hopefully I can try to fill some of those holes that we had before. And if not, it's not a big deal, because we can fill them later. There we go. It's probably good. I'll stop the scan. I'm going to zoom in again, see how I did. Oh, scanner's been disconnected. That's okay. We don't need it anymore. Software's freaking out. I put the scanner down and it disconnected. Oh, okay, it's back. That's okay. We actually don't need it anymore, really. Okay, so that scan looks okay. I'm going to have to fill some holes, but that's kind of good to show you guys anyway. So I'm going to end the scan. I'm going to, again, get rid of all that floating stuff. So I have connected selected right here. I'm going to select our second scan, invert the selections, and hit delete to get rid of all that other stuff. Okay, so there's our two scans floating in space. Now I need to align them so they're about the same and filling the holes of the other one. So I'm going to hit alignment up at the top, and I'm going to do surface best fit alignment. I'm going to do a manual alignment, and the screen splits in two here. And basically what I want to do is I want to line up both of my gears so they're kind of facing me in the same orientation. And you can see, so that bump right there, that's one of our pieces of tape, and this is the other one. And this is where those pieces of tape kind of come in. Try to find the tape on the blue one. I don't even see it. Oh no. Okay, the tape might have not have came through.
You can kind of see it on the other side.
On this side?
Yeah. You can see the triangular piece.
Oh, right there. Yeah, yeah. That should be okay. We'll try it. So in this screen, I want to kind of get them lined up in the same orientation. And I'm going to select 3 points or more, but 3 is usually good enough, on one of them, and then try to select the exact same points on the other one, and it'll match those points together to try to line them up. So I'm going to do it right on top of my piece of tape. I'll try to do it on the other, and then we'll maybe do one of these teeth up here. We'll do this one. Now I'll do the same thing on the blue, trying to get them in the same spot. The only problem is my tape did not come through very good. But that's okay. We'll try it anyway. Maybe? We'll hit best fit. That looks okay. It should be fine for just this demonstration. You can take longer and do more scans, and your results will obviously be better the more time you take. I'm kind of just going through just to show you the project idea. Okay, so we're done with our merging our scan, or aligning our scans. Now we can actually merge our scans up here, which basically makes them into one 3D model. And this can take a decent amount of time. Our part's pretty small, so it shouldn't take a long time, but the more data you have, the longer it will take. Okay. So it looks a lot better now. We obviously do still have some holes, but those look pretty small and we should be able to fill them. So we have our 3D model done. We're done scanning. So now we can go over to the other part of the VX elements. We're going to scan right now. We're going to go to VX model, and there's actually a button at the top right here that says send to VX model. So we will click that. And basically all that changes are the buttons that we have available to us now. There's a lot of different buttons here. I'm not going to go over all of them. The main one for now that I'm going to go over is fill holes. When I click that, it will kind of highlight all of the holes for us. I can just click, and the software will kind of, at its best, fill some of these holes. And I'm just going to go ahead and click through most of them. A lot of them don't matter because we're just going to be using this part as a reference to build our new part. If you do have like a pretty big hole, like this one should be fine. If you have a pretty big hole, you can use some of the other options up here to fill the holes differently using like a bridging kind of way, I guess. But there's a couple different ways you can do it. But this should be fine just for our demonstration. And again, the longer you take on this, it just depends on how long and how accurate you want to be. All right, one more hole maybe right there. Where'd it go? Okay, we filled all the holes. I can hit watertight mesh, and this will watertight the mesh, making sure there are no holes left, which is just a good verification. Okay, so we have our basically our full 3D model now with no holes in it. So the next thing on our list is to create some entities that use the geometry that we can then send over to SolidWorks to recreate our part. So first, I'm going to use these buttons up here. These are the entity buttons to, like I said, create some entities. So first I'm going to make a plane, and I'm going to create a plane in reference to the flat area of my gear here, and hit OK. So that plane is going to represent the bottom of our part. I'll create another plane to represent the top of our part, and I'll want to constrain this plane to the first one that we made, just so I know they're lined up on the z-axis or whatever axis. It doesn't really matter in this scenario, but as long as they're on the same plane. I could add more geometry like planes and lines and dots to try to line my part up to the origin of my workpiece. And if I did that when I sent it over to the SolidWorks, it would line up with the origin of that workpiece in SolidWorks. That's not something I have to do in this because this is a really simple part. And again, you can get really in depth with this with the different tools. I can, grab a circle. I can grab a sphere, cone, cylinder, any of that stuff. But for now, all we need are these two planes, and we need just the shape of our geometry. And to get just the shape, we can do a cross section, which is this one. It asks what plane do I want the cross section to be on. I'll say either of those two planes will work, and I'm going to offset it from that plane a few millimeters. And you can see the yellow line, that represents our cross section. So that is actually grabbing all of the shape of our data that we need. I'm going to hit OK. Jump out of that. OK, so that's all the entities we'll need. I can hit the drop downs here to kind of see each one. I'm going to highlight all three. I'm going to highlight all three. Why can't I transfer the SolidWorks? Okay, highlight all three, and I'm going to hit the transfer to SolidWorks button. This is going to transfer all the things I've highlighted over to SolidWorks. SolidWorks is a 3D CAD software. Amtek can provide this software, and it's used in a lot of industries, so it's pretty much on par, if not more so, than with AutoCAD. So you can see in SolidWorks now our two planes and our cross section. The cross section came in as just a spline line, and the two planes are just planes. So what we're going to do is I'm going to go into the sketch of my cross section. I'm going to turn all of the lines in here to construction lines because I don't actually want to use them for our new model. I just want to use them as a reference. So I don't want to accidentally use them as building the part. And now we can use those lines, like I said, to make our new part. So I have a circle tool here. I'm going to just try to line it up as best I can. And again, you can get as accurate as you want, as long as you want to take on it. But that's probably good. So I have an inner circle. Why am I in markup? I'll make another circle for the outer. Okay, I'm going to make these two circles concentric so they're kind of equal to each other. And now I need to make my teeth. I'm going to use the rectangle tool. Just try to line this up as best I can. That's probably fine. And then I'll trim off these parts that I don't need. My mouse is getting stuck. And now I'm going to use the circular sketch pattern. I'm going to highlight the little teeth parts that I built. Oh, it's all in the wrong circle. I want it to be on that one. It's asking me for the center of rotation, and I want it to be that point. And now I'm just going to up the iterations until my teeth, the little yellow lines, kind of line up with the scan, which should be 12 because I've done this before, and it is. It looks pretty good. I'll hit accept. I'm going to trim off all the other parts I don't need, all these other lines, so that it makes it a full 3D model. Okay, and now I can turn this 2D sketch into a 3D model. So this is where those two planes that I brought comes in. So what I can do is I can choose the direction or the way I'm extruding this model. I can up to a surface, and I can choose the surface to be one of those planes. And then I can do a second direction and choose up to surface and do the other plane. Hit accept, and that should be pretty accurately our part, but with that hole filled in. So that's our part reverse engineered fixed. From here, we can obviously add to the part. What I can do to make my little part easier to move is I can add like a little spinning handle to spin the gears a little easier. So I can sketch just on this plane, on this face here, add a circle. And again, you can be as accurate as you want. And then I can just extrude it by something maybe like 40 millimeters. That's probably fine. And now I have a little handle to spin the gears with. So our part's done. We've modified it. We've repaired it. I can go over to, that's not the button I want to hit. Where's file? File, save as, and I'm going to save it as an STL file. STL files are the most common file type for 3D models most of the time. There are some other ones that are common too, like 3MF, but STL will work. And we're going to send this STL file over to GrabCAD Print, our 3D slicing software. So I'm in GrabCAD Print now, just clicked over to it, I already had it open. This is a template for our F170. We can look at all the other Stratasys printers that they provide. These are all the templates. This does work through the internet. If I was connected to the same internet that our printer is connected to, I could actually just send the job right to it. But I am not, so that's okay. We can save it to a flash drive and move it over there instead. So I'm going to add a model. Let me make it bigger. Add a model. Bring in our part number 3, which is the one I just saved. It came in a little wonky. A good 3D printing practice is try to usually have the biggest surface area touching the build plate. That'll save material and time. So there's a couple buttons here where I can manipulate the part. I'm going to orient face to plane, select the bottom face, and I say I want it that on the bottom, and now it's flipped the right way. There's some errors with the part. GrabCAD Print will auto-detect errors and repair them for you, and it almost always works and keeps the dimensions of the part pretty closely. It shouldn't change it really at all. There's some other modifications that we can do within this 3D printing. In general, you can change the infill, which is the inside of the part, what type of material you're using, how accurate you want it. You can have the filament come out thicker so it takes less time and uses less material, but will look not as well or not as good. We'll keep all the defaults just to show you. Before we send it over, I have to actually slice it, and this is the process that's turning the part into the file type that the 3D printer sees. And you can actually see in GrabCAD Print all of the different layers that the printer will do, which is a nice visual. I can view the estimate down here. This print is going to take 1 hour and 48 minutes. We obviously won't sit here and watch it print. From here, I would put a USB stick in, or like I said, if I was connected through internet, I could hit print and send it right to our printer. I'd walk over, put my flash drive in, hit print as long as the material is loaded. And because I've already done this project before, I printed it. So this is what it looked like when it's finished. The F series has a flexible build plate, so I can just flex it. Oh, not too high, sorry. I can flex it, and it should just snap right off. And there's our part. So our part has some support material. The F series has a support head that prints this soluble support material that you put into a bath, and it will dissolve eventually. Because our part is pretty simple, it just did a little raft for us that I can just peel off. But for something like our gripper, it would have filled all of these different holes in with support, and this is something you would put into the bath, and then when it was done, it would just work. This is called print in place. So we have our new part with our handle. I can pull out our old parts and see if it works. And hooray, it does. And just to show you, this red one was printed on another 3D printer that we provide, a Ultimaker. This is on an Ultimaker S3, but we provide all of the Ultimaker lines. And it doesn't matter the 3D printer, it works just the same. This was sliced in a different slicer called Cura, but it all works the same. And that's about it. That's the project. It's pretty cool, pretty easy to do. Thanks. That's my email down at the bottom. I can answer any questions too. Yeah, thank you so much for joining, and have a good one.